Hey everybody, Lars here. Oh, beautiful coffee. Real quick, am going to do the second review video for the Unit 1 slides. After that, we'll spend maybe 2 minutes doing announcements, and then I will let you get on to your weekend. Although it is only Wednesday, you still have a couple more days to go. All right, let's go. Let's get started. I have something whipped up for us already. And basically all it is up here in the comments, I put the relation operators so you have them. When I'm done with this code, rev2.py, I will put it up in resources so we have it. So really, I just want to go over 3 different concepts. One, the first concept, is the concept of Boolean variables. And they are not crazy. They're a little, I don't want to say counterintuitive because I don't know if it's that, but they're a little odd at first. Basically, a Boolean variable is different from an integer or a floating point number, which is a variable or a cubbyhole placeholder for numbers. And it's different from strings and characters in that it's not really a word. It's almost like the variable is holding a condition. It's holding a binary condition, whether something is true or whether something is false. As you can see here, I can just print var1. And if we save it, remember Control S F5 to do it, and it just prints true. And you may be saying, wow, that's really wonderful, thanks a lot, but it's not very useful as far as, you know, programming is concerned. Where it becomes useful, and if you look above at the relational operators, you can see I can create conditions, and the result of those conditions will be either true or false, and I can hold that result in a variable. Let's, as an example, say we have a variable called number1 and we make it equal to 10, and then I have a variable called number2 and I make it equal to 20, okay? Then I take a third variable, variable3, and I say variable3 equals, and using the relation operators or the relational operators that we use for arithmetic, I can create a Boolean variable in var3 and say, let's say var1 greater than var2. Okay, then I will print var3. Now, what do you think we're going to get? var1 greater than var2. If you look, oh, actually, I don't want to do that. I want num1. var1 and var2 are Boolean variables. Actually, we'll go back and try it later because we'll get some interesting results. Actually, let's see. var1 greater than num1. That's very interesting. We'll go back and look at that, because I think that would be true. var3 equal to num1 greater than number2. If we look up, num1 is 10, num2 is 20. So, is num1 greater than num2? It's not. So, var3 should be false. We run it, and it is. It turns out that that variable is false. But now, as you can see, all we have to do is switch that operation around, and now it's true, because num1 is less than num2. Okay? Now, if you put the equal sign in there, it's less than or equal. So that is true. But now it will also be true if we make it equal to itself, whereas if you got rid of this, that would no longer be the case. Okay? You also have not equal to, which in this case is false, because they are equal to each other. If I change it back to 2, that will be true. Okay? And one thing to remember, I'm going to change it back to 1 so we can do this test. 2 equal signs in a row is the relational operator for equality. Now, we're used to seeing only 1 when we do our arithmetic equations as math students in high school or beginning of college. But in Python and in most programming languages, C, I know, and others, that is an assignment. That means I'm assigning a value to a variable. In order to discuss equivalency and whether things are equal to each other, we use 2 in a row. As you can see up here, I use 2 in a row. Do there, and if I run this one, boom, I get true, because num1 is indeed equal to num1. Okay? So that's pretty much the way relational operators work. You're going to see them in action as we create our conditions, and they have something to do with the homework you're going to do. The second homework, I'll show you some of that stuff. Let's go one step further with the Booleans and not just look at relational operators with math, let's also join them together with some Boolean algebra. So, now, first thing I'm going to do, let's do this. var3 num1 greater than num2. Okay? That should be false, yeah? var3. Yes. So, let's bring our old friend the if statement in there. If var3, don't have to create a condition, we just have to look at the variable. Print. This is true. And in this case, I'm going to do an else, and I'm going to say print. This is false. Okay, so when I run it, it says this is false because I created a Boolean variable, var3, which has the value false in it, and then I tested if var3 is false. So what's below here does not get run. What gets run after the if is what gets run if things are true, and we'll do that in a minute because we'll switch the sign. So because that was false, we went to the else and we printed this, and this is false. Now if I just change that sign around, boom, it says this is true. Because now var3 is true. num1 is less than num2. So if true, print this is true. Now, this looks incredibly simple, and it isn't incredibly simple. But think about what we just did. We have two variables, okay? We tested them against each other relationally and created a Boolean variable, and then we tested that variable to see if it was true or false and did something different depending on what it was. So we now can examine our variables and make decisions about them. As a matter of, when you discuss if then else, you talk about decision making. And I'm going to compare that, and I'm seeing, oh, okay, I can do that. It's powerful stuff, and as simple as this looks, it's an important concept to get because, I mean, you just compare two numbers, and based on what that result is, you made a decision in your program. So you're starting to control things. You're starting to do different things. Now, I don't have to say if var3. I can create conditions right on the fly. So I can say if num1 less than num2 and just create the condition right there. I don't even need var3. Okay? And this is where it gets interesting. This is true because num1 is less than num2. So I can also do this. Let's keep it true. That is also true, but why? When you have an AND as a Boolean algebra operator, both of these things have to be true in order for the whole if statement to be true. So is num1 less than num2? Yes, it is. And is num1 equal to num1? Yes, it is. Now, I say num1 not equal to num1. That's going to be false. What do you think is going to happen? Now it says it's false, because in order for an AND statement to be true, everything has to be true. Okay? Now, how can I correct that? If I just want one of them to be true, if only one of them has to be true to trigger the action we want to perform, I don't use an AND. I use an OR. Now, if one of them is true, then my statement will be true. And as you can see, now it's true. And if you ever had a logical design course, or if you've ever read programming before and you did truth tables, it harkens back to that. Ands and ors are usually done with symbolic logic. But in programming, especially with Python, it makes it really simple. With an and, everything has to be true in order for that whole compound statement to be true. With an or, just one thing has to be true. Okay? Now, I can also change the results of things with the algebra operator not. So if I wanted to, what do we have here? Let's say I have an and. So when I run this, it's going to be false. Okay? But let's say I take this false one and I want to turn it around. So I could say not whatever the result of that is. And it will give me the opposite of it. Now it's true. Okay? So those are the three Boolean operators. You have and, you have or, and you have not. So it's probably a good idea to play around with some of those things. Really, the last thing that I want to get to and the last thing that I want to show you is one last little thing. I guess I could leave that right there. Like I said, when I'm done with this, I'm going to save it. I'm going to throw it up in the resources on Sakai, so you have no worries. Last thing I'm going to deal with is this. Let's set up an if structure and say if num1 is greater than 10, colon, what do I want to do? I don't want to print. I'll just tell you what it is. Num1 is greater than 10. Okay, there we go. Now, I will also say else print num1 is less than 10. Okay. Now, you may have already figured out where I'm headed, but just in case, let me do my little trick. Just get rid of those print statements so they don't get in the way. Let's run it and see what we get. Dun, 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 dun. Why would that give me trouble? Oh. Doesn't see the line. Wants me to block out everything. Okay, num1 is less than 10. Num1 is equal to 10, so if num1 is greater than 10, you know what? I did it right away because it's 10. Usually I have something else here. Let's just say that's 12. Boo. Num1 is greater than 10. Is it? Yes. Because num1 is 12. I showed you the problem first. So, what if it was less than 10? I'll make it 9. Now num1 is less than 10. Okay, my program works pretty good. But as you saw, because we did it the first time, there's a problem here. And what's that problem? The problem is, what if it's 10 itself? Num1 is less than 10. But is it? No, it's not. It is 10. So we have an issue here. And I want to show you how to do this, not just to show you what an elif is, but also to make you aware that sometimes we think we have binary decisions that are either yes or no, true or false, but we don't. In this case, we think we have a binary decision. Are we higher or lower than a particular number? But you've got to remember, what if you are right on that number? Now, we could use greater than equal to and things along those lines. But in reality, in this case, you've got three possibilities. You could be higher, you could be lower, or you could be that number. So what we do in computer programming is we have an elif. And what I'll say is I'll say elif, and then you put the condition right afterwards. Num1 is less than 10. Print num1 is less than 10. And then I can do else. Now, I've tested if it's greater. If it is, I'll trigger it. I've tested if it's lower. If it is, I'll trigger it. There's only one choice left. So if I get to this else, I am definitely 10. So I can say number 1 is 10! Exclamation point. Let's end that. Okay? Because this whole block will run together. If, elif, I could do as many elifs as I want, and then it ends with the else. Okay? So in this case, I'm checking to see if num1 is greater. If it is, great. It'll trigger it and then drop out of the block. Next, if it's not, I will test if it's less than 10. If it is, it will print this, drop out of the block. Now, if I've gotten by both of these, the number has to be 10, as we'll see in a moment, and I will print that out. Okay? And then when I drop out of the block, I'll just print S and G, the end. All right? So, let's see what we get. Well, first, let's get rid of this 10. Let's make num1 20. Let's see what we get. Num1 is greater than 10, the end. So what happened was, if num1 is greater than 10, it is because it's 20. It prints this, it ignores the rest of the block, and it drops out to here and prints the end. And that's how that code is run. Now, what if I came here and I made num1 an 8. I run that. Num1 is less than 10. The end. So now I come down to my block. If num1 is greater than 10, is it? No. So I do not run the true. I come to the elif. Elif, num1 less than 10, is it? Yes. So I run this code. Print num1 is less than 10. And as you can see, that's what got run. And then I drop out of the block, and I print the end. And that's what happened. Now, the real test. I make num1 exactly 10. Let's see what happens. Because as you can see, nowhere do I test if it's equal to 10. I'm making the logical assumption if it's not greater than and it's not less than, it has to be 10. So let's test. Dun, da, da, and it works. Okay? So that I not only wanted to show you the syntax of elif, but I also wanted to make you aware that sometimes we think we have binary choices and we can use if else. But sometimes we don't. Sometimes you have to think out of the box, and you have to be very precise when you program. So be weary of that and watch for things like that, okay? So those are the big 3 things that we really want to keep in our minds when we think about the second half of Unit 1. We want to think about Booleans, true or false, how to create them with relational arithmetic operators. We want to think about Boolean algebra, and, and, or, not, and things along those lines. And you can take this code and play with it, because I'm going to put it up on Sky, as I told you. And we also want to worry about ifs and elifs and things along those lines. As you know, you've received a certain homework assignment. And here, let me call it num3. Let's say num3 is 25, and num4 is equal to 135. And I could write a statement that says if num3 is equal to, my guess, 1, and num4 is equal to, look at that, already making mistakes, my guess, 2, then print, what did I say, winner, or whatever it was? I didn't say bingo. What was bingo? Is bingo guessing both correctly? Yes. Right, bingo. Boom. Whereas up here, my guess, 1 equals int input, guess the age. My guess 2 equals int, I'll fix that in a minute, input, enter, or guess the weight. All right, why did that go down? All right, 25, 135. La 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 la. La 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 la. Run. Invalid syntax. I won't have it. Okay, what happened here? Guess the age. Boom, 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 boom. Think I'm missing an extra quote. Because I'm not just doing input. I'm wrapping it in int because I want a number at the end of the day. Think I'm okay now. Guess the age. What did I say? 25. 25. Oh, not 25 there. 25 here. 25. Guess the weight. What's the weight? 135. 135. Bingo. Okay? So look at that. Right there. That's what I'm talking about in assignment 2. All right? Enough said. I've already given you too many hints. Too many hints. Too many hints. All right. I'm going to save this, and I am going to put that down there like that. All right. We are getting close to crunch time for Unit 1. The quiz is going to be Monday, February 1st, I believe. The assignments will be due at midnight Monday night. I think they technically close at 1 a.m. on the 2nd. But it's Monday night that you got to get me the 2 assignments. You know, you've seen them already. They're not that hard. They're not backbreakers. I go into forums, and I see 11 people have put in their bios in the forum. That means 6 of you have to put in your posts. Do not forget to do so, because if you don't, then you will lose out on 5 points for the unit. And that's a decent amount of points The forum posting is low-hanging fruit. Go in, put in a few paragraphs, tell us who you are. Very simple, 5-10 minutes. Start talking with each other. Read the posts of your classmates. Know where they're coming from, what they're doing, why they're interested in Python. Maybe you can find somebody who's interested in Python for the same reasons that you are. And then you guys can get together and talk about projects and talk about collaboration and other things. That's what we're all doing. We're all in this together. We got to learn Python together. And we will. It'll be cool. So you got no worries. All right. You've got the 2 chapters of Zell. You've got the slides for Unit 1. You've got both assignments now. And now you have both review videos. I don't know if I'm going to have time to do, usually in Unit 1 I do a 3rd video where just from scratch I put together a program and I run it, just so you can see somebody doing that. I might do that, but if I do, I will be creating that video from Global Game Jam, which is a hackathon for creating video games. I'm the fact staff advisor for a university club called COGS, the Creation of Games Society. And what they are is a collection of video game designers, and they meet weekly at the cave, and we also go to different events that do video game creation and video game stuff. And the biggest one of the year is called Global Game Jam. There are 600 sites all over the world, not just the United States, where this one weekend, luckily it's the weekend between the championship games and the Super Bowl, that one weekend everybody goes to this hackathon for 3 straight days. You stay there for 3 straight days. You have to sleep in sleeping bags, and it gets a little crazy if you're an old guy like me and you have a bad back. But you stay there and you create video games, and these are some of the most talented, creative, awesome students in the world. It's video games isn't just programming. It's artists. It's people who do stories. It's people who do music. It's just a really good creative time. Maybe at some point I'll shoot you some links to the games we've created in the past, because we've created a couple good ones over the years. But we're going to do it again this weekend. So it kicks off Friday at 5 o'clock with a big pizza dinner and a whole bunch of different exercises and stuff like that. It's really cool. But I'm going to be there all weekend. So hopefully I'll be able to take a half hour on the side and real quick whip up a Python program while I'm at Global Game Jam. So I'll try to do that. Actually, that's just a cool idea the more I think about it. So I'm going to try to do that. All right, so bottom line, if you haven't done your forum post yet, do your forum post, huh? Easy points, easy points. Work on those assignments because they need to be handed in Monday night, all right? Not backbreakers. You can see them, and if you look at the videos and you engage with the resources, you should be good to go as far as the assignments are concerned, all right? I'm guessing you're going to be fine. If you're not, send me some email. Already have some people coming to the cave tomorrow night. So if you have some questions or you want to, get started right and make sure Python's on your machine right, come to the cave. I mean, that's why we have it. That's why it's there. All right. All right. I'm going to get out of here. You take it easy. If anything comes up, you send me email, and I'll be in touch in a couple of days. All right. All right. You be good. Bye-bye.